Hi everyone, for our CHM 256 video assignment, we will talk about the determination of water hardness. This is our group members. The first one is myself, Jacqueline Grace Matrin. The second one is Nur Arisha binti Muhammad Faisal. And the third one is Nur Shafawati binti Yusof. I'm Jacqueline and I will start with the introduction. The hardness of water is determined primarily by the total of calcium and magnesium it contains, which make it water hard if it have higher levels. It also has important economic and environmental implications such as water quality. In addition, the hardness of water also depends on its source, like groundwater, which will be very hard because it has been in contact with porous rock that containing deposits of minerals. There is a study that has been designed to investigate the drinking water quality in Alipur, Pakistan, which is to prevent water contamination problems because it has been reported that there is a widespread of water-related disease like diarrhea that have caused the vast majority of death in Pakistan. One of the ways the study can be done is through determination of hardness of water, which can be determined by the milligrams of calcium carbonate per liter, and WHO recommend value for hardness limit is 500 milligrams per liter. Besides, studies have generally found that there are no serious adverse health effects linked with drinking hot water, but it can contribute to dry skin. That is why people with eczema are recommended to use water softening system.
Hello, my name is Nur Arisha and I will present the literature review. As we all know, water hardness increases its hardness when the concentration of magnesium ion and calcium ion is increases and become very thick. And first of all, we need to look water hardness effects on organism. One of the notable organism that can be affected by water hardness is fishes because they live in that particular area. That is where their habitat is. Calcium ion plays an important role in several fish biological processes, including ionic regulation, membrane permeability, blood coagulation, bone development, and enzyme activity. Therefore, some degree of water hardness is necessary to help ensure the well-being of fish and may even improve stress resistance. However, excessive water hardness can cause harmful consequences in fish that includes reduced growth, disrupted ion homeostasis imbalance, altered energy metabolism, and even histopathological damage. Next, water hardness effect on human. Notably, calcium ion and magnesium ion act as antagonistic enzymatic activators in human. Calcium ion is involved in nerve impulse conduction, muscular contraction, and coagulation, whereas magnesium ion is essential in cardiac physiology and represent a cofactor in more than 300 enzymatic reactions. Hot water is a dietary supplement for calcium and magnesium. According to the World Health Organization, there is no convincing evidence that water hardness can cause adverse health effects. In fact, some studies suggest that calcium and magnesium, the primary contributors to water hardness, may have beneficial health effects. However, the World Health Organization emphasized that more research is needed to establish definitive health guidelines for water hardness. The reason is because calcium and magnesium is very good for human. Calcium, while not setting a specific limit, the World Health Organization mentioned that drinking water contributes to calcium intake, which is beneficial for bone health. Meanwhile, magnesium, similarly, in drinking water contributes to the daily intake required for various bodily functions. Next is statistical methods are very crucial in water quality analysis to ensure the accuracy and reliability of the collected data. One of the tests that we should do is the Q-test and the T-test because it is very commonly used for statistical tool for identifying outliers and comparing means. This helps in elaborating their application in the chemical analysis of water hardness and the assessment of the physical and bacteriological quality of drinking water. The Q-test is used to detect outliers in small data set. It is very particularly useful in environmental studies where data variability can be high due to natural fluctuation because there can be many factors that can be taken account in, and the test is very helpful in ensuring the integrity of the data by identifying and potentially excluding anomalous values that could skew the results. Next, T-test is a statistical method used to compare compare the means of two groups to determine if they are significantly different from each other. This test is crucial in water quality studies to compare treated versus untreated water samples or to assess the impact of intervention. Or maybe, in addition, it could also mean different places that have different concentration of water hardness. One of the examples for Q-test in a study by Jones and Murphy 2002, the Q-test was applied to the measurement of calcium and magnesium concentration in water sample. By identifying and excluding outliers, they ensure that the calculated hardness value were more accurate and reflective of true water condition. For the T-test example, we can see in Petel et al. 2019, use an independent sample T-test to compare bacteriological contamination level in urban and rural water sources. The study revealed significant differences, highlighting the need for tailored water treatment solution for different environments. Lastly, the chemical analysis for water hardness and the assessment of physical and bacteriological quality are essential for ensuring safe drinking water. We should also take account for the operational consideration, which is hard water can cause scaling in pipe, boilers and household appliances, which can reduce their efficiency and lifespan. Therefore, managing water hardness is important for maintaining the infrastructure and functionality of water system for us. And the application of statistical method like the Q-test and T-test enhances the accuracy and reliability of this assessment. Continued research and methodological advancement are necessary to address the complexity of water quality monitoring and to ensure public health protection.
For methodology, saturation methods are the most common protocol for determination of water hardness, but investigation of instrumental techniques can improve efficiency. As you can see, the picture shows the illustration for titration method. The apparatus used for this method is clamp stand, which used to hold and secure burette in place. The second one is burette, which is to measure the volume of the titrant. The third one is stopcock, used to control the flow of the titrant within a pipe. Next is volumetric pipette, which are used to measure and transfer a fixed volume of hot water sample from one container to conical flask. Next up is conical flask, which are used to mixing and carrying out titration. 6. Measuring cylinders, used to measure liquid volumes. 7. Pasteur pipette, which will transfer small quantities of the indicator. And the last one is white tile, which is used to spotting the endpoint of color change during a chemical reaction.
Next is result and discussion. Here are the sample for determination of hardness of water. So to perform the Q-test and T-test, here are several tests that we must apply. So this is the formula for Q-test. Step performing Q-test, the first one is we must find the suspected value. To find the suspected value, first we must arrange all the data sample in increasing order and we calculate the gap, lowest data sample with the closest value and the highest value with the closest value. If the gap is higher, so it will represent as a suspected value or outlier. Second step is calculate Q experiment. From the suspected value, we divide with range. To get range, we minus highest value minus with the lowest value. And after that, we get the answer for Q experiment is 0.294. And the last step for performing Q-test is we comparing between Q experiment and Q table. If the Q experiment is higher than Q table, the data will be rejected. If the Q table is higher than Q experiment, the data will be retained. Then look at confidence interval. So for 90%, the Q value is 0.56. So the Q table, which is 0.56, is higher than Q experiment, which is 0.294. So the data is retained. Same goes with 95 and 90%. Q table is higher than Q experiment. So the data for the sample are retained. Next, moving to the next part, which is performing T-test. For performing T-test, we must have mean statistical factor we can get from the table for T value, standard deviation, and number of sample. Number of sample is 6. Here, the step of performing T-test. First, we must find mean and standard deviation. Formula for mean is sum all the data sample over the number of sample. After we sum all the data, we divide with 6. And the answer for mean is 284.167. For the standard deviation, here are the formula, and the answer for standard deviation is 92.001. Moving to the second step, which is we must find degree of freedom. Degree of freedom is number of sample minus 1. So 6 minus with 1, we will get 5. Last step for performing t-test is we must find the t-value. To get the t-value, we must refer to the table for t-test. So, the first step, we look at the degree of freedom. Degree of freedom for this calculation is 5. And the confidence limit that we want to find is 90%. So, for 90% is 2.0.5. So, after get the value for t, we substitute all the value for the formula confidence limit. So, for confidence limit for 90%, 284.167 plus minus 75.682. So, there is 90% chance the true mean lies within range from 5%. The t-value is 2.571. So the answer for confidence limit is 2 for mean value plus minus 796.565. So there is 90% chance the true mean lies within range. And same goes the 99%.
In conclusion, the magnesium or calcium concentration data points in water hardness studies are retained across all Q-test confidence level, which mean the data is accurately reflect the true water hardness without any anomalies. And the data set also seems to be homogeneous, which indicating good quality and consistency in the data collection process. By retaining the data point at the 90%, 95% and 99%, enhance the credibility of subsequent analysis and the conclusion drawn from the data. In the t-test, for each confidence level, the true mean is expected to lie within the specified range. And as the confidence level increases, the width of the confidence interval also increases, reflecting more certainty about the true mean being within the interval. This interval can help us understand the precision of our sample means estimate and provide a reliable basis for making decisions based on the true mean of the population. The consistent retention of the data point across various confidence levels suggested the robustness of our data and reliability of our measurement.
This is our references. And that's all from us. Thank you.